Hello, my name is Blanca Elena, and we're going to talk about the subduction zones of North and Central America as the first activity of this COIL. We are Team 5, composed by Delia Isabel González Preciado, Luz María Hernández Soriano, Blanca Elena Pineda Valenzuela, and Luisabel Jiménez Galindo. So first, a summary of our ideas and what we understood. First, in the general gist. The term subduction was coined specifically to describe the newly discovered phenomena. 2 subduction zones are localized in determined areas, generally near tectonic plate borders. Associated with them are parallel volcanic arcs. 3. Slab pull, gravity, is the main force that makes plates move. 4. Earthquakes draw the geometry of the subducted slabs, and this can be seen through seismic tomographies. 5. Mantle wind promotes differences in subduction angle westward due to the Earth's rotation. 6. Transition between lower and upper mantle is at a depth of 660 kilometers. This barrier resists the penetration of the subducting plate, promoting its stagnation. So from the questions provided, the big question we chose to answer was number 2, which was using your preferred browser, search for the IRIS earthquake browser. Select the region of Central America, view it in 3D, and compare it to other regions. We chose a number of these. And then check what are the main differences and why.
Almost 50,000 seismic events are recorded in this database, but we show you 2,000 hypocenter focused mainly in the subduction fronts between the Cocos Plate against North America in the west and the Caribbean Plate against South America Plate in the east. Transfer boundaries occur on the north and south sides of the Caribbean Plate and has lower incidence of earthquakes. Particularly, subduction seismicity beneath Mexico can be recorded up to 300 kilometers inland, and this promotes an oblique volcanic arc, unlike Central America, where the volcanic arc is parallel to the trench. The deepest earthquake recorded for this subduction zone was at a depth of 200 kilometers beneath Guatemala. We show you these graphs. The first one is the frequency of magnitudes histogram that shows 2 peaks on 2.9 and 4.5 magnitude. Next one, we can see that most of the earthquakes occur at shallow depths, gradually decrease in frequency. The next one, small pike, hits almost at 147 kilometers. In depth and versus magnitude graph, we might have a positive correlation. The Eastern Mediterranean has 2 main subduction fronts in just 5 kilometers. For example, the first one, African Plate, produces the Calabrian front beneath Eurasian Plate. This is beneath Italy. And the deepest earthquake took place at 5,000 kilometers. And we can see it in the upper right 3D image. The Hellenic front records shallower earthquakes because a lack of the subducting slab beneath Anatolian Plate. And we can see it in the second 3D image. Also, the frequency of magnitudes, we can see it at an average of magnitude 3 to another family of distribution between 3.7 to 4.2. The depths are most very shallow, between 0 kilometers and 41. There is a gradual decrease with 2 small spikes at 100 and 150 kilometers and 290 kilometers. In the depth versus magnitude graph, there is 3 main groups.
Okay, I'm Blanca Elena, and I'm going to talk to you about the subduction zone at the south of Japan between the Pacific Plate and the Philippine Sea Plate. First of all, to the left, we have an image of how the plates are distributed. We can also see that we have a small area where we also have a second subduction right next to the first one between the Philippine Sea Plate and the Eurasian Plate. So at the image to our upper right, we can see the main subduction where we have first very shallow data that is widely distributed, and then we have at the deeper points, which are in orange, we have a very straight line. At the image at the bottom, we can see how they are distributed at depth, And we can see that we can still see this relationship where we have a very shallow subduction with the green points. Then we have very vertical uh, earthquakes in yellow, but they're less abundant. And then we have again a flattening of the earthquake epicenters in orange and red. Here we can see another 3D perspectives. This one seen from the other side, where we can see again that the yellow points are less abundant. And what are the main characteristics of this area? First, that there are two plates subducting very close to each other, and that there are very few earthquakes between 100 and 150 kilometers. And most earthquakes in general are relatively close to the surface or very deep. The deepest earthquake here was at 583.8 kilometers in the Bonin Islands in the Japan region with a magnitude of 4.5 in the Richter scale. Now, we did a little bit of distribution here in histograms. So first, the frequency of magnitudes is very normally distributed in a typical bell shape with mean or average of 4.32 to 4.40. The frequency of depth has a bimodal distribution where we have a very large peak at depths between 0 and 48 kilometers and a very small but wide peak between 336 and 456 kilometers. And finally, in the depth versus magnitude graph, we have an hourglass-shaped graph where we have very few earthquakes at depths between 200 and 300 kilometers, which was very similar to what we saw in the yellow area in the previous images. And when there are earthquakes at that depth, they tend to be at a magnitude between 4 and 5.
Hi, I am Delia, and I'm going to talk about the Tonga subduction zone. So here we can see the Tonga subduction zone, which is located in New Zealand, Fiji, and Vanuatu Islands, and of course the Tonga zone. I tried to represent the geometry of the plates in this black and white image, and we can see the Pacific plate subducting the Australian plate, both very vertical. The Pacific plate moves around 6.9 centimeters per year in the Tonga region, and Australian plate moves around 5.1 centimeters per year. We can also see four segments of the subduction zone in the 3D image, and we can also see the plate structure. The largest earthquake was around 8.2 magnitude and occurred around 600 kilometers near Fiji, and the deepest earthquake occurred at 697 kilometers and had a magnitude of 4.1. Here we can see three graphs. In the depth versus magnitude graph, we can see these two zones where most of earthquakes happen around 0 to 300 kilometers depth and 5 to 700 kilometers depth. Also, in the frequency of magnitude, we can see a positively skewed graph with the average of magnitude between 4 and 5. We can also see in the frequency of depth graph that there is a gap between 220 kilometers and 420 kilometers, where we don't have as many earthquakes as in other depths. And this could be explained with the gap between lower and upper mantle, but this is just a supposition.
Hi guys, I'm Luz. Here we have the South America subduction zone when the Nazca plate subducts under South American plate. First, we can see that the most earthquakes are at relatively shallow and these shallow earthquakes are at shortened distance from the trench. On the other hand, only a small parts of the earthquakes are found at depths greater than 500 kilometers, and in general, the deepest earthquakes are at a greater distance from the trench. In fact, the deepest earthquake is located at 630 kilometers deep with a magnitude of 7.1, very far from the trench. Here we can see the depth of the earthquakes. In the scatter plot, we can see that there is an absence of occurrence of earthquakes in the range of 350 kilometers to 500 kilometers. And in the histogram of frequency of depth, there is a kind of trend in which at greater depths, the frequency of earthquakes is lower.
So the main differences between Central America and other subduction zones, first of all, are the plates involved. For example, in Central America we have the Cocos, Caribbean, and North American plates, and in the others we have from Eurasian, Arabian, African, and Anatolian plate. Passing through Pacific and Philippine Sea plate. Also, we have Pacific and Australian plate, and even Nazca and South American plates. The other difference we found was the max depth of the earthquakes. For example, in Central America, we have around 226 kilometers, and in the other subduction zones, we have from 500 kilometers to almost 700 kilometers. Also, the angles of subductions in the Central America, we have coupled angles of subduction from 25 degrees up to 80 degrees. And in the other subduction zones, we have from very shallow, like the Eastern Mediterranean, and even very large angles. For example, the Tonga subduction zone with around 70 and 80 degrees. And for example, in South America, and in the Japan subduction zone, we have from low to moderate, and it's very variable.
The main difference between Central America and the other subduction zones can be stated as follows. In Central America, we have an absence of earthquakes deeper than 226 kilometers. The volcanic arc in Mexico is oblique to the trench. There's a single spike in depth data around 33 to 41 kilometers. And meanwhile, the other areas have deeper earthquakes and double spikes in depth data. As questions that came up during our activities, we have the following. First, in petrology, why does the addition of water to the magma under the continental plate lower the fusion temperature? Could other fluids besides water modify the fusion temperature? Regarding plate structure, we have in the central part of the Mexican subduction zone, why is there an abrupt angle change? What causes the plates to break? Do convection cells have something to do with this? Regarding depth and data, why does the IRIS earthquake browser only show earthquakes up to 800 kilometers in depth? Why is there a limit there and not deeper? Regarding correlation, true or false, is there a correlation between the depth and magnitude in the Mexico Central American region? Why or why not? This is regarding this graph here. Regarding upper crust deformation, we have two. What are the consequences of surface deformation between a steep slab and a flat slab? What is the role of sediments in subduction here? And finally, why does compression by subduction create distension on the surface, back arc and fore arc? Thank you very much.